Math 2415, Vector 10, what am I saying? Math 2415, Chapter 10, Vectors and the Geometry of Space, Section 2, Vectors, Video 9, Vector I, Vector J, and Vector K. The physicists and engineers amongst you probably already know about these vectors. In the event that you don't, allow me to introduce them. I, J, and K are very specific vectors depending upon if you're talking about R2 or R3. In 2 dimensions, and I guess I should say V2, vector I is the unit vector in the x direction. In other words, if we're on the x-axis, it says go 1 to the right, and that vector would be 1, 0. Vector J is 1 unit in the y direction, in the positive y direction, and so that vector would be 0, 1. That's all they are. But in R3, where we have an x-axis, a y-axis, and a z-axis, I is still 1 direct unit in the x direction, and J is still 1 unit in the y direction, but now K is 1 unit in the z direction. So in R3, vector I in component form is 1, 0, 0. Vector J in component form is 0, 1, 0. And vector K in component form is 0, 0, 1. So they're just very special unit vectors. All of those have a magnitude of 1. If you think about it, it makes perfect sense. So what's up with all these IJs and Ks anyway? Well, because in 2 and 3 dimensions, vectors can be written in component form. They can be drawn as arrows, but they can also be written in what is called IJK form. For example, let's take the vector 3, 2, -5, and let's break it down. We're going to break it down by writing it as the sum of 3 vectors. The first vector is 3, 0, 0. In other words, it captures the first coordinate only, the first component only. The second vector will be 0, 2, 0, so it captures the second component only. And the third vector is 0, 0, -5. So it captures the third component only. Think of them as displacements in the x, y, and z directions. Now, none of these are I, J, or K because those all have 1s. However, I can unscalar multiply it by factoring out a scalar of 3 from the first one, leaving the vector 1, 0, 0, factoring out a scalar of 2 from the second one, leaving the vector 0, 1, 0, and factoring out a scalar of -5 from the third one, leaving a vector of 0, 0, 1. And by factoring out those scalars and leaving behind 1s in each position, I've just exposed I, J, and K. So we could write this vector as 3I plus 2J minus 5K. Now that's a lot of hoops to jump through just to write this in a different form, but it shouldn't surprise you that the coefficients of I, J, and K match the components in the original component form. So in general, if you have a vector in component form, we'll call it A, B, C. Then in I, J, and K form, it's AI plus BJ plus CK. And if we were in 2 dimensions, then there would just be an I and a J. IJK form is a physics and engineering thing. It really doesn't change anything that we do. If we wanted to add, we would combine like terms. If we wanted to do scalar multiplication, we would just distribute the scalar to each thing there. I think IJK form is an attempt to take component form and make it look more like algebra instead of an ordered triple. But either way, it works the same. During the class, I will predominantly use component form, but every once in a while I'll use IJ and K form just to mix it up. Just keep in mind that it's just 2 different ways to represent the same thing. I'm sure there's something else I should say about it here. I know what I want to say, but we haven't talked about cross products yet, so I'm not going to say it. Okay, so yeah, IJ and K form, just a different way to write a vector in 2 or 3 dimensions. I don't know if a 4-dimensional analogy for IJ and K form. It'd be interesting to research it though.